Quadratic functions, parabolas, example number 3. All right, here we have a function here, f of x. Once again, it's a parabola because it's got x squared in it. And so I would hope with a little bit of practice and experience, you would recognize that this would indeed look like f of x equals ax squared plus bx plus c. And so really this one's ready to go right off the bat. We can identify the fact that a is -2, b is equal to 4, and c equals -5. All right, so ABC. We're just going right through the cookbook here, and we'll find these we'll find these parts here to the parabola, and as we find them, we'll put them on the graph. All right, so the formula for the axis of symmetry is x equals -b, which in this case is 4, divided by 2 times a, which in this case is -2. A little bit of arithmetic. The numerator is -4. The denominator is also -4, and therefore -4 divided by -4 is 1. So x equals 1. So looks like scaling the x-axis by 1s makes sense. And so you'll have the graph paper there on your homework paper, and you'll go to the 1 on the x-axis and draw that vertical line right there. So that's cookbook. Make sure you're very careful when you do that, that your arithmetic is solid. So as we've seen on the previous 2 examples, once we have that value of x, that becomes the x-coordinate of our vertex. We dump it right in there, put it right in there. This is an ordered pair, it's a point, parentheses, comma, 2 numbers, all right? And then we put 1 into the function, so f of 1 would equal -2 times 1 squared plus 4 times 1 minus 5. And to be a snob, that's just arithmetic, order of operations. So when we apply the order of operations to this, let's see, you would square the 1 first, which is 1, times -2 is -2, plus 4 times 1 is 4, and minus 5. Again, board space, sorry, I'm doing the best I can, but it looks like this would be -3. And so, all right, I'm thinking the y-axis is conducive to scaling by 1s as well. And therefore, we'll go plot that ordered pair. X is 1, y is -3, ordered pair, point, boom. All right, so we're done with that. Direction. You remember, hopefully, that the direction is determined by the value of a. And in this example, if a is -2, -2 is less than 0, bring these notes up. They were sent to you, right? And if your value of a is less than 0, that tells us that this will be a downward parabola. It'll be a frown, right? And that's how it should appear from now on. That'll have implications moving forward that are pretty important that we'll talk to here in a little bit. All right, y-intercept. Every point on the y-axis is a point of the form 0 something. We put 0 in for x. That's easy. Whenever you put 0 in for x here, in both of these places, those terms that have x disappear, and you're left with that -5 sticking out on the end. So that's easy. We go to the ordered pair 0 on the x, 0, right here in the middle, right, horizontally, and then -5, 1, 2, 3, 4, 5. There you go. So you got that. Okay, now, what could be the tricky part of this question if we're not paying attention? Whoop, whoop, pay attention. Look at this. Our vertex is right here. Let's talk about x-intercepts. Here's your x-axis, right? Here's your x-axis. Our vertex is right here, and we determined earlier that this thing opens down. And I hope you could use critical thinking, visualization. I don't know what else to say. I hope you could look at this and say, you know what, if this thing opens down, there's no way it's going to hit that x-axis. And you wouldn't waste your time looking for x-intercepts, and you simply write the word none, and you're done with it. Okay? Now, I mean, this is the one that Mr. Sauerkraut sees all the time, where people spend all kinds of time trying to find these x-intercepts on this question, and it doesn't have them, and they waste a bunch of time. I will tell you very quickly that if you do try to find them, here's what's going to happen. You will eventually get to where you would be doing the quadratic formula and you would run into the square root of a negative number, which is imaginary, and then you go, oh yeah, that's right, there weren't any x-intercepts. So I don't know what to tell you. There's not a math formula for this. Visualization. This is why, one of the reasons why it makes sense to plot your vertex and determine the direction before you look for x-intercepts. All right, those two pieces of information taken together should tell you this thing ain't going to hit the x-axis. All right, and so basically what I would tell you is use symmetry to your advantage. Here is your vertex. You've got your y-intercepts, so you're going to bring it through here, and then just draw the mirror image of this on the other side the best you can, and that's good enough for me. All right? So not all parabolas have x-intercepts. How am I going to know? Visualization, critical thinking, I don't know what else to say. All right? So be careful on that part of it. Take the information you've identified earlier, which would be the position of the vertex and the direction it opens, and if that doesn't match up with having x-intercepts, write the word none and be done with it. All right, let's come back and enjoy two more parabolas.